coming up. Good afternoon, everybody. Welcome to sunny late fall afternoon of Chem 170 Organic Chemistry with your host, me, Dr. White. Better roll down my sleeves, look more professional. Right. But anyways, all right, important information. Remember, Wednesday, I will be giving test number 3 right after our lab. I have in the announcement, I said at 4 p.m., but I'll probably send out the email with the password for the protected PDF file, test number 3, right after class on Wednesday. You'll have until 11 a.m. Thursday morning, take test number 3, scan it, or however you get to your answers into a PDF file and upload them to D2L. And it'll just be like in the past. I'll also be available Wednesday afternoon for my office hour in case you have any questions, or email me, even though Wednesday evening I'm occupied. So when I get back from where I have to go, I'll check my email if you have any questions. Now, test number 3, as I've mentioned, will cover carboxylic acids and their derivatives, esters and carboxylate anions, and amines, amine salts, quaternary ammonium salts, amides, and heterocyclic compounds. That's a lot. And today, I'll be doing my world famous review for the next test, test number 3. I'll go over the amines problem set, which I haven't done yet, and then we'll do new stuff. Plus, I've got a show and tell for you. Yep. Did I tell you when I was in grade school, teachers used to always were afraid of my show and tell. Why? It was always science related, and if it was English class where you're supposed to give a talk in front of the class with a show and tell, teacher and nobody else in the class understood what the heck I was talking about in my show and tell. One time I brought in a flashlight and a piece of polarized film and talked about polarized light. Oh, she was upset with me, that teacher, because she had no understanding anything I had said. But anyways, let's get back to chemistry. First of all, not first of all, but I do want to remind you, next Monday, I'm going to be having the first of 2 cataract surgeries. I'm nervous about it, but it's a good surgeon, so I should stop being nervous, so I won't. But anyways, that means we won't have class next Monday, but I will be putting in my YouTube channel a video of all the material I would have covered next Monday, except for one thing. That's test number 3 answers, going over it. I'll do that a week from this Wednesday, when, God willing, I'll be back safe and sound. And I'll go over the test answers then. But everything else I'll put in a video. I'll send out an email this weekend to remind you about that. Also, I should have your grades and your point total for each question. All right, any questions so far? Well, in that case, let's get started with the review. All right, thumbs up, people. You see test 3 review on your screen. Thank you. All right, what you see is available in Blackboard in the lecture folder, cleverly named test 3 review. All right, first we started with carboxylic acids. A carboxylic acid has a carbonyl, carbon double bond to oxygen, with a hydroxy group and an R group. And for the IUPAC name, find the longest chain with the carbonyl carbon, name it as an alkane, drop the E, add the letters OIC and the word acid. Remember, for alkyl groups on the R group, the carbonyl carbon is number 1. All right, there are a couple of common names and a common /IUPAC name you need to know. And the first one, when R is a methyl, that's acetic acid. By the way, you take 4% acetic acid and 96% approximately water, and you have vinegar. And then formic acid, when R is an H, it can be, formic acid undergoes all the reactions. This is about all that carboxylic acids undergo. And that's the acid that's the fire ants use as their defensive weapon. And finally, when R is a benzene ring, you have both the common and the IUPAC is called benzoic acid. Again, once again, their infinite wisdom, and I do mean this truly, and they did such a wonderful job and have been doing, that IUPAC said, well, we're not going to change these organic chemists. They've been calling the structure of benzoic acid for centuries. Well, let's call it that too. Now, a carboxylic acid is an acid. Acid is a proton donor. In a carboxylic acid, the hydrogen on the oxygen bond to the carbonyl is acidic. For this class, I'll stick to these types of bases, MOH, hydroxide bases, where M can be lithium, sodium, or potassium. And when that happens, remember, I only ask for the organic products, not inorganic most of the time, like 99.8%. And you get the carboxylate anion. You don't have to show charges. I do, because good habits I don't change. Next, you have a carboxylic acid reacting with a special base, and that special base is sodium bicarbonate, NaHCO3, which is also baking powder. And when that happens, if you look at the problem set for carboxylic acids and esters, I ask, give all the products. In this case, you get the carboxylate anion. Here, M is sodium, and you get water and CO2, carbon dioxide. The arrow up tells you it's given as a gas. And as I mentioned, well, I think it was when we talked about a week and a half ago or whenever, remember the little rocket ships where they had the candy in there, but you dumped the candy out because it was awful. And my father showed me how to put a little vinegar and baking powder, put the cap on. The CO2 built up in there because it's a gas, and the top, boom, flew off about 3 to 5 feet if your timing was good. And when you're 6 years old, that's amazing. And it's still, my memory reminds, I can picture doing it with my friends when we lived in Chicago. I don't live there now. And it was still, it reminds me of a fun time. Also, since sodium bicarbonate, baking powder, is a base that neutralizes some of the acid, I also told you about my father's recipe making tomato sauce or spaghetti sauce, really, that's a better name, proper name. And at the end, he put in a small amount of baking powder to neutralize some of the acid from the tomatoes, citric acid, and that made it milder and smoother. Also, don't tell anybody, you also put a little pinch of cinnamon in, but that's for a big pot. How do you make a carboxylic acid? If you take a primary alcohol and oxidize it, you'll get a carboxylic acid. If you take an aldehyde and oxidize it, you'll get a carboxylic acid. And one of my favorite, but then again, you know, I have a soft spot in my heart for Grignard reagents. You take the Grignard reagent, react it with carbon dioxide, CO2, it attacks the carbonyl of CO2, which is actually a carbonyl carbon, and second step acid and water. H plus is acid, H2O, I hope you all know, is water, and you get a carboxylic acid that's 1 carbon longer than the R group you started with. Next, we talked about esters. Ester has the structure carbonyl, R group on the carbonyl, oxygen, and then another R group, which we call R prime, on the oxygen bond to the carbonyl carbon of the ester. Now, the way IUPAC has is you name R prime as the alkyl group it is, and you put that in the front of the name. Now, IUPAC uses 2A. You pretend R prime is a hydrogen, name that a carboxylic acid to make that ester, drop from the carboxylic acid name IC acid, and add OATE. So you have two parts. Now, I had a Chem 170 student a number of years ago, was quite sharp, and he came up with a method. When R is not benzene right here, you can use his method, B2. I'd say to be or not to be. Oh, I can't resist saying that. Shut up, Dr. White. Okay. Anyways, name the alkane name of the chain with the carbonyl carbon, which is, well, get back, R plus this carbon, name that as an alkane, drop the E, and now add OATE. You still have in front the name of the R prime as an alkyl group. And don't forget, my special gift to you is that for esters, I will not have any alkyl groups on the R group because it gets quite complex when that, and I'm going to give you a special gift. Now, there's a special ester you should know, and that's this one. Nobody calls that ethyl ethanoid. I have to think a while to think about it. It's ethyl acetate because it comes from acetic acid. And it's a common name. Remember, for common names, if I give you a structure, you should. If I give you the common name, you should be able to draw the structure, at least for esters, carboxylic acids, and carboxylate anions. It's the only one here of the ester. And remember, ethyl acetate is one of the two molecules that's used as nail polish remover. The other one was the ketone acetone. Now, at this point, I could now, which I did in our lecture, talk about carboxylate anion nomenclature, also sometimes called carboxylate salts, but I like anion myself better, even though it really is a salt. And you name M plus as the element it comes from in front, like if it were sodium, and A plus would be sodium. And then you use the same number 2 for esters, which is either 2A or 2B, or not to be. I can't resist the I. But anyways, and you use that for the rest of it. And that's how you name carboxylate anions. Now, important thing you should know, esters are responsible for the smells of flowers and the smell and taste of fruits and vegetables. Speaking about which, don't forget to turn the lab that's due this Wednesday on Wednesday. You guys have been really good, and I appreciate it. Thank you. My other class at COD, I'm having a lot of trouble with about a third of the class getting them to turn in labs, and they're not going to be happy. Great time. They're missing a lot of labs. I can only do so much. But anyways, if you happen to smell or taste a banana or apple or other fruits and vegetables, you're smelling and tasting esters. Now, how do you make an ester? That is the Fischer Esterification, and that's taking a carboxylic acid plus an alcohol with acid catalyst, and you make an ester. The oxygen in R prime, oxygen in the ester is bonded to carbon and R prime that the hydroxyl group in the alcohol was bonded to. I'll say that again. The oxygen in OR prime is bonded to the R prime carbon in R prime that was the same carbon in R prime of the alcohol that had the hydroxyl group. Now, when you have an ester, you can react it with acid and water, and you get back the carboxylic acid and the alcohol you use to make that ester. And as you learn, that's how your body breaks down fats and oils, which are all triglycerides, 3 esters. Now, when you react an ester with base and water, which is called saponification of an ester, and I won't ask names of reactions. I never do. And here M can be lithium, sodium, or potassium. You get the carboxylate anion of the carboxylic acid you would have used to make that ester plus the alcohol. Why? Because the carboxylic acid immediately forms with the base to form the carboxylate anion. And next, I started talking about an area that was near and dear to my heart, which is amines and amine derivatives. What's an amine? It's a nitrogen with R groups on it and hydrogens, or just R groups. And here, this is a primary, secondary, and tertiary amine. I won't ask that. An important thing to remember, carbon has 4 bonds to it. Nitrogen can have 3 or 4. When it's an amine, it will only have 3 bonds to it. And later on, when I talk about amides, it will have 3 bonds to it. But quaternary ammonium salts, which I'll mention in a second, have 4 bonds to it, covalent bonds, and so do amine salts. So you can have either 3 for amines or amides, or 4 for quaternary ammonium salts and amine salts. Now, because anybody works in the industry, which I have and still do as consultant, nobody uses IUPAC names for amines. They use common names. So on test 3, the nomenclature problem, here's the structure, give the IUPAC name, which will contain both esters and carboxylic acids and amines and their derivatives, will now say, give the IUPAC or the common name. This is the one exception this semester. And how do you do that? Name each R group on the amine as an alkyl group, and at the end of the name, add the word amine. And there's no special order which name goes first. Now, there is a special amine I would like you to know. That's when you have NH2 on a benzene ring. That's not called benzene amine. It's called aniline. Again, IUPAC in their infinite wisdom, this has been called that for eons, made it both the common and the IUPAC name. Now, something really near and dear to my heart are quaternary ammonium salts. That's when you have 4 groups, alkyl groups, R groups on nitrogen, and has a plus charge because it gives both of its non-bonding electrons to form a bond to one of the R groups. And then because of that, all molecules have to have a net 0 charge. Therefore, you have a counter ion. In this case, counter ion, I'm going to do the halides, which are X can be chlorine, bromine, or iodine. Could be fluorine, but I haven't talked about that all semester, so I won't. It's very rare in the real world anyways. Now, how do you name a quaternary ammonium salt? The common way, which I'll ask you to know how to do, name each R group as the alkyl group it is in the front. At the end, add the term ammonium halide. When X here is Cl minus, it's chloride. When X is Br minus, it's bromide. And when X is I minus, it's iodine. Now, amine salts, which we'll talk about, you have here where our prime and our double prime can be one, both, or none, R group hydrogens. And how do you name that? The same as quaternary ammonium salts. And students always ask, well, how do you know if it's a quaternary ammonium salt or amine salt? Well, quaternary ammonium salts have to have 4 alkyl groups. Amine salts never have 4, 3 or less. All right, how do you make an amine? First of all, you can start with ammonia and react it with an alkyl halide, RX, X can be chlorine, bromine, iodine. The nitrogen attacks the carbon with the halogen, and you get an amine. That's why you have the base to neutralize the amine salt that's actually formed here. And you get the amine, a primary amine. Notice amine, 3 bonds to nitrogen, R, and 2 hydrogens. Now, if you take a primary amine, I'm getting ahead of myself, and react it with R prime X, alkyl halide, again, X is chlorine, bromine, or iodine, in the presence of base, you'll make a secondary amine, and again, 3 bonds to carbon. By the way, the bond to nitrogen and R prime, and the same thing, the bond to R from ammonia, here, this nitrogen, is the same carbon that has the halogens. Again, the bond, in this case, say to R prime and R prime X, right here, that nitrogen will be bonded to the same carbon that has the halogen. Now, once you get a secondary amine, you can react it further to make, again, with our double prime X, alkyl halide and base, a tertiary amine. Notice 3 bonds to nitrogen, so that's why there are no hydrogens in that one. And finally, this is really near and dear to my heart because it paid for a couple of cars and got me around the world and a whole lot of other nice things. You take a tertiary amine and react it with an alkyl halide, R triple prime X, in the presence of base, nitrogen bonds to the carbon and R triple prime with the halogen, and you now have 4 groups on there with a plus charge counter anion, which comes from X here, and you make a quaternary ammonium salt. If it looks like I'm smiling, I am. And that's how you make quaternary ammonium salts. Now, an excellent way of making primary amines are if you take a nitrile, which I didn't ask you to learn the functional group name, or it's IUPAC or common nomenclature, they're both, but it's got a triple bond, carbon nitrogen triple bond, 2 pi bonds, 1 sigma. If you react it with excess hydrogen and a catalyst can be nickel, platinum, or palladium, you break the 2 pi bonds, and each atom of the carbon nitrogen triple bond gets 2 hydrogens. And you can write it this way, but notice this is CH2, 2 hydrogens on that nitrogen, NH2. Which reminds me, I better talk about something real quick. And that's not what I wanted to click to. Hold on, I thought I opened it. Ah. Now I know why I never opened it. Let's try this again. All right. Thumbs up, people, or both of you. Thank you. One of your colleagues emailed me yesterday. They had an orientation program they had to go to today. All right. Remember this. I can write this secondary amine this way. Or I can write it this way. I can write this tertiary amine this way, or I can write it this way. And remember, when you see brackets and a number subscript to the right of the right bracket, everything inside is repeated this time, 3 times. And if I were to have this compound, And by the way, even though this is bonded to Br minus really to nitrogen, we put it to the right of the last, this part of the structure. You could also put it here if you want. But anyways, you can also rewrite this. Notice it has 2 methyl groups on nitrogen and 2 ethyl groups. You don't have to show charges, I will. And then the anion. So I just want to remind you, using these brackets or parentheses, parens, is how we write things shorthand. And we do, and I do that on tests. All right, now, amines are bases. And for reacting with an acid, and for this class, I'm going to use the acid HX, hydrohalogen acids. X can be chlorine, bromine, or iodine. Remember, R prime and R double prime can be hydrogen. You make an amine salt. Next, I talked about amides. Amides is where you have a carbonyl, carbon double bond to oxygen, and R group on the carbonyl. The carbonyl is also bond to nitrogen, and you have R prime and R double prime. Now in amides, R prime and R double prime can be hydrogens. Oops, I almost forgot about something. Dr. White, you should remember what's an important use of quaternary ammonium salts. One is as a fabric softener, like in the sheets or the liquid. I like those special effects I'm using, not. And remember, I told you a story about my gums and needing a good, I had a prescription mouthwash, and then when that dentist had to retire, I hadn't found a new one. My prescription ran out. I found that Scope mouthwash, or the Walmart equivalent, has a quaternary ammonium salt. Remember, quaternary ammonium salts, certain ones have very strong antimicrobial properties. They kill bad, nasty things, in this case, in my mouth. Now, back to amides. So this is an amide. I didn't ask you to learn any nomenclature, IUPAC or common, both exist. How do you make it? By the way, S-I-N is Dr. White being lazy. It's short for synthesis. How do you make it? If you take a carboxylic acid and react it with either ammonia, NH3, or primary secondary amine, that's what I mean by R prime and R double prime can both be hydrogen, or one or two, well, if they're both one or none, or they're both R groups, and you make an amide. And here's our amide. Now, we'll learn later on, amides are how you make amino acids, which is quite important. If you like protein in your body or to eat, you like your skin, your hair, or in my case, what's left of it. But anyways, that's how you make an amide. Now, once you have an amide, what can you do with it? Well, react it with acid. And for this class, I'm going to use HCl. Why? Because that's the acid in your stomach, and water. And what you get back is the carboxylic acid you would have used to make that amide, like from this reaction. But since amines are basic, the amine you get when you do this acid hydrolysis of an amide, immediately, it's the quickest reaction known in all of chemistry, reacts with the hydrochloric acid to form the amine salt. So don't put the amine down here for this reaction, or I'll mark it wrong, because in the presence of acid, it's going to form the amine salt. Now, you can also react an amide with base and water. For this class, I'm just going to use sodium hydroxide. You can use potassium and lithium hydroxide, but In real life, you usually use sodium hydroxide. And here, what happens? You get back the carboxylic acid. But wait, you have the carboxylate anion because carboxylic acid in the presence of base, acid-base reaction, there's nothing faster in all of chemistry, immediately reacts to give the carboxylate anion of the carboxylic acid you would have used to make that amine. Plus, you get the amine that you would have used because in base, amines are bases and they don't react. Now, I just asked you to learn just two things about what we call heterocyclic compounds. The first thing is, what is a heterocyclic compound? And that's a ring with carbon atoms and other atoms such as nitrogen or oxygen. That's a heterocyclic compound. And as I mentioned, but I won't ask on a test, those are responsible for most of the compounds in our daily life are heterocyclic. Not all, but the high majority. And that's organic compounds. All right, I asked you to learn the structure of one heterocyclic compound, and that's this one, pyridine. It's like a benzene ring, except you substitute one of the carbons with nitrogen. The N. Does anybody have any questions about the review? I guess not. You know something? I think it's time for a pick-me-up, something to make you nice and happy. And I have just the thing, and that's circle and name the functional group, 2 points each. Ooh, when I'm looking at my fingers, hold on. I'm in a good mood today. It's Monday. I washed and waxed my car yesterday, and the weather was just right. So let's play that exciting game. I better ask because at the other class Friday, I thought I had. Everybody see that fun game on your screen I'm writing? Thank you. All right, have fun. Circle and name the functional groups, 2 points each. I should find some game show music that I could play, like The Price is Right or something, which I haven't seen in decades. Dun, 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 dun. I think that was from Jeopardy. I have to remind myself over the weekend. I hope you all did. Well, you did because you're here on time. I changed all the clocks in my house. I think I've got about 14, things like on my thermostat, I have a clock, on my oven, my coffee maker, which is really my tea maker, my microwave oven, and the list goes on. And above my monitor, I have one clock, which lasts since many months. It's about 2 minutes fast. And when I change it now, I got to remind myself it's right on time. I finally fixed it so it'd be equal to the actual time. And when you're done, give me a thumbs up. Thank you, Calvin. Let's be patient. Give everybody time to finish. All right, let me get to work. Let's play that fun game. Circle and name the functional group, 2 points each. And how do you play that? Well, for this chapter, and most of the time, you look for what's different. What's not carbon, what's not hydrogen. Ooh, look right here. What do we have here? Carbonyl with oxygen with R group, and other R group. This is an ester. Now, you don't have to write this, I will, but you should circle. If you had circled the whole thing in this one, that's okay. Next one, ooh, oxygen's here and here. We have carbons to the carbonyl, but now we have a negative charge, M plus. And remember, M can be for this class, sodium, potassium, or lithium. And what is this? This is a carboxylate anion. And now let's look at C. What's, ooh, different, nitrogen on a carbon what is this an amine? Again, you don't have to put primary, secondary, tertiary. By the way, that's a primary. If you want it, that's okay, but you don't have to. That's an amine. Are we done? Oh, no. There's oxygens here. What do we have? Carbon, carbonyl hydroxyl group. And what is that? Sorry about my bee looking funny. It's even too funky looking for me. Hold on. That's better. You have a carboxylic acid, which has this function right here. I forgot to put here. And if we go back now to D, and I just realized I forgot one functional group, so I'll give you one. What's different? Ooh, carbon, carbons here, carbonyl, oxygen, carbons. This is an ester. Ooh, what do we have here? Nitrogen. Notice it has a plus charge, but it has not 4 alkyl groups on it, less than 4, 1. And what is this? This is an amine salt. And finally, right here, near and dear to my heart, notice 1 plus 3 methyls is 4 R groups. They could be the same or different. Positive charge and a chloride. That should be Cl minus anion. Sorry about that. And that's a quaternary ammonium salt. And the one I just realized I forgot, so I'll show you right here. And what's the functional group here? And that's an amide. And an amide has this functional group where R prime and R double prime can be hydrogen. And that's how you play that fun game. Circle and name the functional group, 2 points each. In reality, if you can't identify a functional group in a molecule, how are you going to name it? You can't. If you can't identify a functional group in a molecule, how are you going to know what reaction it will undergo? You can't. So even though it's a fun game, circle and name the functional group is also very important in terms of understanding organic chemistry. All right, any questions so far? Well, in that case, let's go. Remember, there's no such thing as a dumb question in my class or in my world ever. Let's go on to the amines, amides problem set. we'll do a little, take our break, and finish it up. All right, now notice here, unlike other problem sets, and also you'll see this on test number 3, it says, oh, excuse me, give the IUPAC or common name for the following. And here I made a mistake. That should be N-butylamine. Sorry. And you have 4 carbons on a nitrogen. That's the butyl group, N-butyl, and that's an amine. If we look at B, we have, what do we have? Ethyl group and isopropyl. You could just as easily put isopropyl ethylamine. Both would be correct. C is the name aniline. Now, once in a while, Dr. White goes overboard. Just cross off D. I shouldn't have put it down there, but this is ethanolamine, and diethanolamine and triethanolamine are used to adjust pH, their bases in cosmetics, excuse me, and personal care products, such as skin creams and other things. Did I tell you that a lot of personal care items, skin creams, and I'll show you later on, show and tell soap, are very sophisticated organic chemistry. So is nail polish. It's all very sophisticated organic chemistry. Now, if we look at E, what do we have that's different? Well, it's the same as playing that game, circle and name the functional group, 2 points each. We have a nitrogen with a plus charge. It has 4 alkyl groups, 2 methyl groups, 2 ethyl groups, and an anion, that's a quaternary ammonium salt. And you name each R group as it is if we're an alkyl group. And there's 2 ethyl and 2 methyl. You could just easily put dimethyl, diethyl. Then since it's a quaternary ammonium salt, ammonium and Cl- is chloride. Now, G is an amine salt. Notice we have 1 alkyl group, but 3 hydrogens, and it's got a plus charge and the chlorine anion. And what is the R group on there? And propyl, and you have ammonium chloride. If I look at the clock, it's time to take a 5-minute break. I'll see you at 1:55. Dr. White's going to get up and stretch, and I'll see you come back in 5 minutes. time to get back to work. You're wondering what I do, because I'm a little older than you if you haven't figured that out. My podiatrist also, when I hurt my back, physical therapist last year, I hurt my back. There's certain leg exercises I do with this steps downstairs when I go from this level down to my living room area from in my house, that I stretch all the muscles in my legs and my get part of my lower back too. And that makes me feel nice and comfortable. The joys of having mature muscles. All right, let's get back to the amines amides problem set. And here, draw the condensed structure. Again, look at this ethylamine. Remember, for amines and amides, you have 3 bonds to nitrogen. For quaternary ammonium salts and amine salts, you have 4. And this is ethylamine. Here I have tert-butyl ethylamine. Doesn't matter which side you put the T-butyl group and which side you have the ethyl group and hydrogen. Now, cross off C. I said I wouldn't put that on there, and you don't have to know that. And something near and dear and very special to my heart, D, ditallow. For tallow, remember, I'm asking you to use this R sub T. You learned in the fats and oils problem set, or the lipids chapter, not problem set, that tallow is a large R group. And ditallow dimethyl ammonium chloride, that's one way of writing it. There's another way on nitrogen, have 2 R sub T, 2 methyl. You don't have to show the charges. And by the way, don't forget, that was until about 15 years ago, the only molecule used for fabric softener. They changed this R sub T to something a little cheaper that also was more biodegradable, which is a good thing. And again, I went out, I should now cross off E, just forget about that. None of the above, just cross it off. And finally, F, methyl tert-butylamine, nitrogen with a methyl group on one side, a T-butyl group on the other. And notice I can put the hydrogen underneath or to the right of the nitrogen. And you could also have those 2 on either side, then all 3 of them. All right, draw the products or condensed structure of the organic products for the following. And if we look at this, what do we have? Ammonia. What's different here? Carbon with a halogen, alkyl halide makes a primary amine. Remember, and I keep on stressing this because it's a common mistake on test number 3, that students put too many bonds to nitrogen. On amines, it should only be 3. And if here now we have a primary amine, an alkyl halide, the chlorine, presence of base, the nitrogen attacks the carbon with the halogen. In this case, the second carbon of 3, and therefore this is the product you get. And finally, our reaction that's near and dear to my heart. Why? R sub T is tallow. This is a tertiary amine, R prime and R double prime, alkyl halide, methyl chloride, and in base you make a quaternary ammonium salt. And here we have ditallow dimethyl ammonium chloride, which helped make me a lot of money when I worked in the chemical industry. And if we look here, we have a primary amine or an amine with hydrochloric acid, and you make the amine salt. And in this case, you add 1 more hydrogen to nitrogen and it has a chloride anion. Now, if you didn't put the charges there, I would give you full credit. And I gave you some more. And finally, G, I went overboard, cross off G, that you shouldn't, I won't ever put that on a test. All right, now let's do another reaction that actually the first reaction I worked on when I went in industry. So that's near and dear to my heart. Oh, that was a long time ago. A galaxy far, far away. And what do we have different here? Carbon nitrogen triple bond. Remember, it has 2 pi bonds, 1 sigma. If I reacted with excess hydrogen, nickel catalyst, and remember, you can have a catalyst, I didn't have down here, but it could be nickel, platinum, or palladium. You break the pi bond, and each atom of the triple bond, there are 2 pi bonds, gets 2 hydrogens. Now you can write it this way, or you can write it like I did, CH2, NH2. In this case, R is ethyl, and this is what you get. And a benzene ring is not going to react under these conditions, so you get this an amine. And oh, look, I did the chemistry instructor's favorite trick on a test, put a big, scary R group, and I did. But if you know, look for what's different, what's not a carbon, hydrogen, or carbon-carbon single bond, and the nitrile carbon nitrogen triple bond gets you on, it's a triple bond, and there's nitrogen. You react it with excess hydrogen, a catalyst, and you break the pi bonds, 2 of them, and each atom of the triple bond gets 2 hydrogens. And you could have written this also CH2, NH2. Now, what do we have here? Ooh, carboxylic acid, an amine, primary amine. I don't have down here, but R prime and R double prime can 1, both, or none be hydrogen, and you form an amide. And here R is methyl, R prime is methyl, and R double prime is one of the hydrogens. Now you could have written this one here NHCH3 instead of having the H pointing down. And here in L, we have a carboxylic acid, because ammonia will not react with a benzene ring under these conditions. You have to add some other things to make that happen. That's something I do not teach in this class, so you'll never see that on a test. And we have a carboxylic acid, ammonia, and here I'm an ammonia, NH3, R prime and R double prime are hydrogens, 1 plus 1 plus 1 is 3. And you form this amide. Now, don't forget, amides have 3 bonds to it, which is why this is NH2. I see students for this reaction put an extra hydrogen, make an NH3, and up here too, they'd put another hydrogen, so you'd have 2 on that. It isn't. 3 bonds to nitrogen in an amide. And here I just put a big scary R group, and you can write it this way, an amide. I gave you another one. Now, once you have an amide, which has in O this structure, R prime and R double prime can both 1 or none be hydrogen. And what you get is, if you react it with acid, HCl, and water, you get back the carboxylic acid you would have used to make that amide, plus the amine. In this case, when it's ammonia, you get ammonium chloride, NH4, which means you really don't have to write that down. In this reaction, I'll never put on a test. Let's move to the next one. And here we have an amide again. How do you know? Carbonyl. Carbons on the carbonyl. Nitrogen with stuff on the nitrogen. That sounds. And here, what do I mean by stuff? R prime and R double prime. 1 or both can be hydrogen. In this case, 1 is, the other isn't. And when you react it with HCl and water, you get acid hydrolysis of an amide. You get back the carboxylic acid, in this case, benzoic acid. You could have you would have used to make that amide. Now, R prime is methyl, R double prime is hydrogen. And notice you get those on nitrogen with two more hydrogens than a chloride anion. So if I have two hydrogens and I add one more, that's three. And you can write it either way. Notice this nitrogen has 1, 2, 3 hydrogens, and I can condense it like this or leave it like that. And here I just put a lot of big, scary groups on there, but are these 5 carbons. Ooh, I forgot to remind you of something. Remember, for test number 3, a couple things that will be important. Do you break carbon-carbon single bonds? No. And other thing is, how many bonds to carbon? 4. Also now, how many bonds to an amine or amide? 3. How many bonds to a quaternary ammonium salt or amine salt? 4. Those will be your friends. Now, if we look at, say, S, well, this is a long problem set. We got a lot to do. If we have, what do we have here? We have, and let's S, we have carbonyl, nitrogen with stuff on it, and carbonyl with our group. This is an amide. Remember, R prime and R double prime can be hydrogen. In this case, one of them is, and we're reacting with sodium hydroxide and water, base and water. And this is base hydrolysis of an amide. You get back the carboxylate anion of the carboxylic acid you would have used to make that amide, plus the amine you would have used to make that amide. Because in base, amines aren't going to react, but carboxylic acids do react to give the carboxylate anion. In this case, what's our benzene ring? So you get this carboxylate anion, sodium benzoate, and our prime is methyl, our double prime is hydrogen. Notice you also add one more hydrogen. So 1 + 1 is 2, plus it has the methyl group. And here I made a mistake. Oops. Oh, oops. Let me write this down on a piece of paper so I can do it correctly. And let's do this one correctly. Let's see if I counted correctly. 1, 2, 3, 4, 5. I did. And why don't you try this one first, and I'll do it. Because I got it wrong on the problem set. Oops. I don't know what I was thinking. If you notice, I put a lot of big and scary stuff in there. All right, thank you, Megan. We'll wait for everybody to be done. Everybody's done. And look at here and identify what's different. What functional group are we dealing with? And we have a carbonyl, nitrogen, stuff on the carbonyl. And that nitrogen, which is bonded to the carbonyl, has stuff, alkyl groups, which I'll call R prime and R double prime. Remember, both of these, or one or none, can be hydrogen. And when you react that with base sodium hydroxide and water, you get back not the carboxylic acid, you would have made that amide, but the carboxylate anion of the carboxylic acid, and you do get the amine. So here's R. Doesn't matter which one you can call R prime and R double prime, and therefore the carboxylate anion that's our carbonyl O minus Na plus. You don't have to show the charges, but I will. And then our amine hold on. That is the most awful. Let me move this out of the way here. Is this. And you could have the methyl group and the benzene ring. Don't forget, benzene ring has those double bonds. Make sure you put them in there because they don't disappear. And that's how you do that one correctly. Now, on test 3, like test number 2, we'll have about 3 or 4 synthesis problems. And if we look at A, what do we have? We have a secondary amine. How do you make it? React an alkyl halide with a primary amine. Well, I can call the methyl group R and the ethyl group R prime. If that's the case, we have methylamine, the top right here, and you could have any halogen, because in this one I don't give it to you, and that would be R prime ethyl, and halogen I just picked bromine. You could have put chlorine iodide. Now, you could have called the ethyl group R and the methyl group R prime. In that case, this is the amine you get. And what's the alkyl group or the X, whatever you want. R prime is methyl, and both of these would give you the same product. And a similar, what are we making? Quaternary ammonium salt. And here, what's R prime, R double prime, and R triple prime? Well, there are different ways you could parse it. And here are the 2 ways you can do that. Now, C, what do we start with that we react with hydrogen excess and a catalyst, nickel, to make this. And the question is, what is this? Look for what's different. It's an amine, primary amine. And what do you start with? You start with a nitrile. And the carbon on the nitrogen, NH2, is the carbon triple bonded to nitrogen in the nitrile. Therefore, R is ethyl. That's what you got. And did I put it down there? No, I didn't. I just realized I didn't put, hold on one second. No, I did. I thought I forgot to do that. And here, what do you react with acid and water to make a carboxylic acid, an amine salt, and that's an amide. And here R is on the carboxylic acid. Notice R prime and R double prime, one or both can be hydrogen. In this case, R prime is N-propyl, R double prime is hydrogen, or you can parse it the other way around. And this is the amide we get. And if you take something and react with base and water, you get a carboxylate anion, excuse me, and you get an amine, what do you start with? An amide, carboxylate anion, and amine. And here again, hold on, I need some water. Something in my throat and it's not a frog. Hold on, test, 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 ketone, it works now. All right, now here, what are you getting? Carboxylate anion and the amine. And one of these, R and R prime, can be hydrogen, both, or in this case, one is an alkyl group, ethyl, the other is the hydrogen. So here we have R, the amide, R, ethyl, carbonyl, nitrogen, with a hydrogen and ethyl group. And that's the problem set. Excuse me. Hold on one sec. Sorry about that. That monster problem set. I was talking forever. Well, I'm done. Any questions about amines or amides? Or any of their derivatives? Don't forget, the next time you're looking at a fabric softener, whether it's on the sheets or in the bottle, it's got a quaternary ammonium salt that's making your clothes nice and small, soft. And also with the winter coming up, quaternary ammonium salts help reduce static on your clothes. I haven't seen it for a while. They used to sell product that was a spray can, especially for women who had certain types of dresses made of rayon and others that would get a lot of static electricity in the dead of winter when it's real dry, and they'd wrinkle up while you're wearing them. You spray a little on there, and what it does is it helps dissipate the charge. Dr. White worked in that area too. All right, well, let me close some stuff down. And let's get back to fats and oils, which we were talking about. And let me open that file up. Now, let's go over it again. This material I'm doing now won't be on test 3 this Wednesday, but will be on test 4. We're talking about fats and oils or lipids, triglycerides, And one of the things I taught you was the following. And I showed you where this is my abbreviation for oleic acid, where you have a double bond in there. If you react it with hydrogen catalyst, you'll hydrogenate the double bond and get stearic acid. And based on that, you have a highly unsaturated fat or oil, probably most likely an oil. And usually I don't put this excess there because I'm an oil chemist. You just know you have enough hydrogen. What would be the product of that reaction? I'm going to let you have some fun and do it. And when you're done, give me a thumbs up. Thank you, Megan. Thank you, Calvin. All right. Now, hydrogen and nickel will not react with an ester. It doesn't. So immediately I can write this down. Now, this is a sterile group, CH2, CH2, on, and CH3. No double bonds. So that won't change. R sub S. However, R sub O tells you there's a double bond in here, just like right here. And what does this become with hydrogen and catalyst? R sub S. So up here, the R sub O becomes R sub S, and down here, the R sub O also becomes R sub S. And this is the structure. Remember, hydrogen and catalyst will not, under the conditions I've ever worked with, react with an ester. And I've done this reaction to the tune of 40,000 pounds. Actually, I supervised it in a chemical plant. And why do they do that? Because this now is a solid or semi-solid at room temperature. this is a liquid. You start with, say, vegetable oil, and they can take this product, hydrogenated fats and oils, or in this case, just an oil, and turn it into margarine, make a lot of money, and they did. I told you that story last week about what happened when I worked for Unilever. All right. Let's move on. And it's time for you to get clean. Get clean? Yes. Let's learn how soap works. And it's time for Dr. White to be subtle. Now, there's something called surface active agents. These are chemicals that work at the surfaces of things, such as your hands in dirt, your hands water and dirt, and the name has been shortened to surfactants. And two of the three companies I work for made surfactants. And what is soap? Now, soap, if you're talking about the bar soap, and it's time for Dr. White show and tell. Look, I have wrapped in here a bar of Dial soap. It's my favorite. I like that spring, what is it, spring water? And you can see this side. Nope, I was right. It all falls out. Here's the ingredients label, which you can't read, so bear with me while I or so go out to the internet. All right, does everybody see on their screen right in the middle, soap? Thank you. Now it says sodium tallowate, and sodium tallowate is the carboxylate anions that come from the reaction of base with animal fat, tallow, beef fat, and that's sodium stearate and sodium oleate. Now, it also has some smaller carboxylate anions, sodium palmitate, 16, cocoate mixtures of 14 and 12, palm kernel, small amount. It's got some water and it's got talc in there. Now, notice how they have the little star by coconut oil, palm acid, palm kernel acid, tallow acid. That's because if they don't do a good job adding enough base, you might have a little in there, and that's to protect themselves. They also add a little glycerin and PEG. Let's see if I can find a. Nope, this is not what I want. PEG methyl ether. And let's see if I can find a better example of all right, everybody see that on the right part of the screen now, where it says drug facts and everything? All right, if you go down to inactive ingredients, because this is antimicrobial, and I'm sure that's what they mean, you'll notice they have PEG methyl ether. That's where you take methanol and react it with 6 moles of ethylene oxide. And that gives it a little thickener. Glycerin does that. Why did they put sorbitol in there? To make it taste good, I guess. I don't know. And then sodium chloride affects the viscosity when they're making it. And pentasodium pentaate and tetrasodium, however you pronounce that, are preservatives. And if you notice titanium dioxide, that's the pigment color to make it look white. And this is soap. And if you notice, oh, there's my favorite Dial soap, which I like. And it's got something antibacterial too, organic molecule. I don't think it's a quaternary ammonium salt. There are other molecules that are also antimicrobial. So what does this mean? What's soap? And you should know soap has the following structure. Well, the one in Dial soap, oops, wrong color. Mainly tallow, R sub T, meaning 18 carbons, including a carbonyl with and without a double bond. That's from oleic and stearic acid. You make the carboxylate anions. Now, another way of thinking of soap, any soap, also your liquid soap, it has a nonpolar tail, CH2 groups, and this you should know, and a polar head. Now I'll explain what we mean by nonpolar and polar in a little while. One way of thinking of it is the hydrocarbon tail is sometimes called lipophilic, lipo meaning fat loving or nonpolar, and the polar head is sometimes called hydrophilic, it loves water. Now, the most important thing, the key, how soap works is like dissolves like. And if we were in a board in a classroom in a room in ECC, I would write on the board this big or bigger. This is the whole key, how soap works, like dissolves like. What does that mean? What like dissolves like, and it's a rule of thumb. A rule of thumb is mostly all the time true, but not 100%. So that's why it's not called a law. That things are certain polar things are soluble in polar things, and non-polar things are soluble in non-polar things. And if you try to mix two together, they're not soluble. Like dissolves like. And let me rewrite it. And you should know this. All right, like dissolves like, polar substances are soluble in polar solvents, and nonpolar substances are soluble in nonpolar solvents. When you mix two together, guess what? They're not soluble, they separate. And being subtle again, and know this. Now, what are polar things? Well, what's polar? And you should know this. The most polar thing in our universe is water. Water is polar. Also, alcohols. Another thing, salts like sodium chloride. But the most important thing, water. Now, what's nonpolar? Well, vegetable oil is, gasoline is, baby oil is. That's how it keeps the baby's bottom dry. And also sometimes used for that, Vaseline is nonpolar. Now, the most important thing I can put down here, nonpolar, are dirt. Yes, think of dirt as a chemical, has properties, and grease, which are the two things you get, say, on your clothes. So, like dissolves like, you have polar substances are soluble in polar solvents, and nonpolar substances are soluble in nonpolar solvents. And if you've ever seen an oil vinaigrette dressing, you can shake it up, put it on your salad. What happens to the bottle afterward? It separates. Why? What really is an oil vinaigrette dressing? Other than the seasonings, it's vegetable oil and vinegar. And what's vinegar? You should know that's acetic acid and water, mainly water. And it's polar, nonpolar, like dissolved like says, that's going to separate. It doesn't say but it separates. All right. Now, let's look at a piece of dirt. Let's say you have a piece of dirt on your hand, and I've greatly magnified it. You should know water won't take the dirt off. Yeah, but if you use soap, and you should know the structure of soap is a nonpolar tail and a polar head. And the soap sees the dirt. Dirt is nonpolar. So the nonpolar tail of the soap is attracted to the dirt. The polar head wants to stay as far away from that. And you use more than one molecule, use lots. I'm just going to only show a few. And when you have the soap this way surrounding dirt, that forms what we call a micelle. And you should know this is a micelle and what the structure of a micelle is. And now the micelle, which let me show you a picture if you were bought the book, looks like this. They cut out a section so you can see inside. Right in the center where all the tails are coming to, there's that little piece of dirt. And notice there are other pieces of dirt that get trapped on your hands and have micelles, this blue sphere, which this cutout would not be cut out. It would also be the minus charges of the carboxylate anion, the polar head. These spherical shapes are called micelles. Now, when water sees the micelle, all it sees is the surrounding polar heads. And water says to the micelle, hey, micelle, I'm polar, you're polar, let's go down the drain together. And they do. And that's how you get your hands clean, your clothes clean. I washed my car and waxed it this weekend. I got my car clean with the soap I use. By the way, Rain Dance automotive soap is the best out there. I've been using it for years. And guess what? It goes down the drain. And same thing when you wash your dishes or your hair or anything else with a soap or detergent. They work the same way. All right, I'd like to go through this again because this is probably one of the most important things I will teach you this semester. How does soap work? First, you should know soap has a nonpolar tail and a polar head. And what's the key principle that is used to make soap work? Notice I've gone to a monster. Oh, how did that S get down there? Light dissolves light. If it wasn't for that, none of this would happen. That's the key part of the explanation. How does soap work that you should know? And when you have dirt, which is nonpolar, the nonpolar tail is attracted to the nonpolar dirt. And you should know when the dirt particle is totally surrounded by soap, in the way I have it pictured, we call that a micelle. And water looks at dirt and says, well, you're not polar, I want no part of you. But now water looks at the micelle and says, oh, micelle, you're polar, I'm polar, because it only sees the outer part of the micelle. Let's go down the drain together. And they do. You should know. Now, interesting thing, first of all, I need a water break. Hold on. Number of years ago, Chem 170 student, she came to me and said, have you heard about micellar water? I said, no, bring in an ad. And she did. And the magazine with an ad in it. And if we go out to the internet, you can see a lot of products now sell what's called micellar water, simple micellar cleansing water, and all these. You know what? There are no micelles in there. There's soap. It's when you put it on your face or whatever you're cleaning, that's when the micelles are formed. I looked at that and let's see. If you look at the ingredients, water, now the hexylene glycol, these are different things that help form micelles when you use it. But there's no micelles in micellar water. Bet you didn't know that. Now you do. This won't be on a test. Oh, I went a minute over. Let's take a break. Come back at 2:51, and I'll see you in 5 minutes. I can get up and stretch again. Oops, sorry, I wanted to check something. Don't forget, I don't know if you can see it. That's organic chemistry. Now, how many of you are familiar with, I forgot to do the, let's get started. I was just checking something. And like I said, if you missed it, that's organic chemistry. Now, how many of you use liquid hand soap or liquid soap in the shower or stuff like that? I use the hand soap. I still like my bar soap when I take my shower. In fact, this morning, I'll bet I was the only one in the whole northern Chicagoland area was thinking while I was taking my shower, oh, look, I'm making my cells. And I was. But anyways, if you look at liquid hand soap, and this won't be on a test, and I'll talk more about it when we do a lab. Liquid hand soap is similar. And again, because like the cells like. Now, unlike bar soap, and this won't be on a test for the liquid hand soap or this structure either, where R sub T is tallow, this plus the carbonyl, 18 carbons with and without a double bond. They found for liquid hand soap, these are called sulfonate anions. This is one, then another variation of this. And this is the other. And here and here, you have your nonpolar tail. And this won't be on a test, but, and this is your polar head. And it works just like anything else. If you have a polar head, nonpolar tail, you have a surfactant, and this happens to be very good at cleaning. Now, the advantage of this is, one, you don't get as much bathtub scum. Now, what's the worst for me personally job in my home? I live alone, so I have to do it myself. I'm not going to hire someone to do it. What's the part I hate the most? And that's cleaning the bathtub scum or the shower scum. Downstairs, I have a shower. Up here, I have a shower bathtub. It gets on the walls of the bathtub and also on the tile walls. You've got, especially in the bathtub, if you let it go too long, it gets sort of thick and, well, years ago, 45 minutes, an hour scrubbing. And finally, one day I said, I don't know if I said actually, but I said, you're an organic chemist. There's got to be a better way. Well, as you learned on the carboxylate anion lab, this won't be on a test, but this will help you. If you have bar soap or R sub T, and you have in water calcium salts, what happens? They're also anions. You get this. And this is a solid that is your bathtub scum. And again, you don't have to write this down, but you'll understand why I'm teaching you this. That will be quite helpful. Now, it's been found if you add an acid to this, it breaks down to give you carboxylic acids, which are more soluble than this dicarboxylate anion calcium salt. Well, where can you get acid that's not going to hurt you? Well, one is vinegar. But vinegar, which is acetic acid, is only 4% acetic acid. And it doesn't do that great of a job. It's better than scrubbing for 45 minutes, but still not that good. So I was thinking about it, and I was looking at things, and I found an interesting product that my sister was using for her, at that time, brand new Viking oven. If you've never heard of Viking ovens and ranges, they're quite expensive. And her stainless steel refrigerator freezer. And that product is the following. It's called Barkeeper's Friend. And everybody see that on your screen right now, the gold, thank you. All right, now, what's the ingredients in there? And if you look on your screen, it's got feldspar, which is something just granular like sand, but not as bad. It's got a soap, that's the sodium dodecyl benzyl sulfonate, and it's got oxalic acid. Well, what's oxalic acid? And oxalic acid has this structure. It's a dicarboxylic acid, and it's a solid at room temperature, which is why they put it in. And this helps break down things like grease and oil when you're trying to clean a frying pan. But this diacid will also help break up the bathtub scum, because the acid here, and what actually happens is, again, this won't be on a test, but you'll be glad that I taught you this. This is a diacid. And when you react this, what you get back, you make this salt smaller to get back this carboxylic acid, plus you make there's only one of them. I really shouldn't have to put a bracket there, but to help you see it. And this is much smaller. And now both of those are water soluble and they go down the drain easily. So how do I do this? How do I make my life easier? Well, let me give you Dr. White's secret, how to clean a bathtub with a lot of bathtub scum really quick. Now, what you do is, and I have my bathroom, both my shower and my bathtub shower have the removable heads. I turn on hot water and spray down the wall and also the sides of the bathtub, or in the shower, the base and the walls, and also the glass door. Then what I do is I take some Barkeeper's Friend, it's a powder, and shake it on the wet walls and bathtub walls. And then with a paper towel, don't use sponges because they get fouled up, wet paper towel, I just make like a paste, the powder that's on there, I spread it out a little more. Sometimes if it's a really nasty area that's got a lot of bathtub scum, I'll put some on the paper towel and put a little more on there. Then I'll wait 10 minutes, just go in another room, do something else, and come back with paper towels, or the green 3M scrubbing pads that you can cut into different pieces so they last longer. That's the secret my sister taught me. But anyway, it's no longer a secret. But anyways, and with the paper towels a little moist, you just scrub the real bad parts, or scrub. That takes about 5 minutes. We're not talking like scrub, scrub, scrub. And then take the shower head, hot water, boop, boop. It's done. What used to take me 45 minutes, so because I let it go too long. I don't like doing it, period. I still let it go too long, but what took me a lot of time, keep on scrubbing and everything, takes me about 6-7 minutes of my time, maybe 8 when you consider washing, getting it wet, putting it on, doing a little scrubbing here or there, real light, and boom, it's gone. Now, the liquid soap, when it forms the calcium salts, has a different solubility, so that's why it doesn't build up as much as with the bar soap. And now you know the secret to how to clean a bathtub. You buy this product. I know my local food store, Valley, has it. I know, I haven't looked for Jewel because I don't go to Jewel that much. I go to Valley. I know Walmart has it. I think Target has it. Just about everybody has it. Don't buy it on Amazon. They rip you off big time. Oh, I take it back. Jewel does have it. And this stuff is really good. Even Home Depot has it, and Ace Hardware. It's everywhere, and it works good on stainless steel. That's one thing I wanted to tell you about. Now, there's another thing I wanted to talk about that, again, this won't be on a test, but I've got some time. I looked at the schedule during the break, and we're doing good, so I can do this. And that is what happens if your kitchen or bathroom sink, or in the case of your bathroom, the bathtub or shower stall gets stuck up, plugged up. Well, one thing you can do is call someone to route it out. And when I bought this house I'm living in a long time ago, I just moved in. I've been there, I don't know, less than 6 weeks or so, and my kitchen sinks got stopped up. I figured, well, instead of me going and getting a drain cleaner, let me just call in the right somebody to route it out. This is my case, to router guy, and get it done, because I'll explain why I did that in a little while. So I called up, looked in the Yelp or Yellow Page, wherever, back then everyone was the Yellow Pages, called someone in the area, and he came out, the Roto-Rooter guy, did it, opened it up, thanked him, paid him. He had said, you've got I think 3 or 6 month guarantee. I said, all right, thank you. Within a week, it was clogged. And I was working full time in the chemical industry. So being alone, I'd have to stay home and wait for him. So I called him up. He said, oh, I'm sorry, I'll come out and do it again. So he did. It's open. And within a week or two, it's clogged again. Now I'm getting frustrated, not because of the money involved. That was not I was wasting a lot of time having to wait home for him to show up. So he comes the third time. He says, oh, I really apologize. Besides routing it, I'm going to put this stuff in there that will really clean it out. I said, can I look at the label? I'm a chemist. And I looked at it and I saw it was just some soap and a few surfactants that was not going to get the job done. So he put it in there and said, rot it out, clean it. It's going to stay that way. Well, within a week or so, guess what? It was clogged. And I'm not putting any kind of grease or anything like that down. I'm very careful. I don't put any grease or fat or any stuff like that. And I also don't use my disposal that much. I just put it in the garbage for pickup. But anyways, so I figured I'm wasting all my time waiting for this guy to show up and he's not getting the job done. I've had enough. So I went to my local Home Depot and I went and looked at the drain cleaners and they had a whole long wall, at least, I don't know, 7 or 8 shelves high, at least as tall as I am, even a little taller. I'm 6 foot or 5'12", and it's got to be at least 5-6 feet wide, lots of them. So I picked up one, looked at it and said, oh, acid, hydrochloric acid. And I'm picking hydrochloric and all that. And then one of the gentlemen who worked in that area at Home Depot came up to me and said, can I help you? I said, sure. All these drain cleaners, which one does the plumbers use? And without even thinking, this like that quicker, he said, that one. And he points to one area where there are a number of bottles, and they were black bottles in a plastic bag. On the plastic bag, heavy Ziploc bag around the bottle, had a big warning in bright red letters, wear proper eye protection. The rest of the drain cleaners weren't that. What was it? Well, let me show you. Oh. And it's got a real catchy name, hair and grease drain opener. So everybody see the black bottle here? They have a whole bunch of other stuff, but here's a large bottle of it. You see that on your screen? And so I looked at he gave me the bottle, I looked at it, and when I looked at the label, which you can't see the ingredients on this one, it had sodium hydroxide, potassium hydroxide. And those are bases. All the other ones that I picked up were acid. So I said, oh, okay, I'll get this. It's different because this has got a base. And immediately said, no, it's got an acid. I said, excuse me, I've got a PhD in organic chemistry. This is sodium potassium hydroxide are a base. And he said, no, it's an acid. And I realized, wait a second, he helped me out. Am I going to argue chemistry with someone in Home Depot when I know I'm right? No, I thanked them, took it home, followed the instructions. The only thing I did differently was when I say let it sit in the drain for 15 minutes, I gave it a half hour. And instead of turning on the water, because it took a while, it takes a while for my hot water to get hot, I took a bucket from my utility sink of hot water and poured it down and did a second one, then turned on the water and let it run for a while. And boom, it was clean. And about every 10 years, if it clogs up, and it's only done it one other time, I mean, maybe it was more like 15 years, I keep a bottle in the house, poured some down there. I wear safety goggles and I wear a long sleeve top, or I also have lab coats, and I wear gloves just for protection. Never had a problem. And a number of my students have done the same. They have used it and it works. It works good on hair. it works good on grease. How does the drain cleaners work? I'll teach you later on how it gets here. This won't be on a test, but in your kitchen, you're going to put down, and it will solidify a fat or grease, which is essentially fat. And I'll use this designation. I could have used R sub O, R sub S. And this is what clogs up your drain. Now, an acid like HCl or sulfuric acid will break this down to these components, which are much more water soluble and here this would be like stearic and oleic acid. Now, if you add base and water, say sodium hydroxide, excuse me, you get glycerin. Again, this is base hydrolysis of an ester. You get back the alcohol. Say, now you get the carboxylate anion of the carboxylic acid you would have used to make that ester. And for some reason, which I don't know, this is a much better reaction in terms of faster and more higher yield. It cleans it out better than using acid. Much better. Now, one other thing that I haven't been talking to plumber later on, I had to have a plumber because I had a clogged sewer line, and that you don't use drain cleaner for because it was from the roots from my tree and a couple of trees in the front of my house. I was talking to the plumber. I was saying, I'm using this stuff now. Is that what you use? He says, yeah. You know why you shouldn't use acid? I said, no, I haven't thought about it. Said, in your house, older houses like mine, which were made in the 1970s, I think now they're not, but you have cast iron pipe going to, which I still have, clay pipes, which are my sewer line. Well, guess what? Acid and iron? I said, yeah, chemical reaction. Use acid, it's going to eat away at your pipes coming out of your house. He said, yeah, that's why we tell people, don't use acid drain cleaner. So a number of my students have used it over years. My brother-in-law used it. I've used it 2 or 3 times. Well, actually, about 3 or 4 months ago, I've been in this house over 20 years. My bathroom sink drain was really almost clogged up. I said, oh, wow, it's been a long time. So what did I do? Use that same hair and grease, pour it down there, let it sit a half hour, pour hot water. I got some from the bathtub, and boom, it's like it's brand new. So that's my special gift to you. And one other thing I figure while I'm doing things you should be aware of, and this one, what's a wax? I'm sure you've all heard of waxes, like beeswax or anything. Well, waxes are esters, simple esters, where R prime and R are very long or you can say big, a lot of carbons. And that's all waxes are. They're not triglycerides. Now, the one interesting misnomer, ears wax, your wax in your ears is not truly a wax per se. It's a hydrocarbon like Vaseline, a little different, more complex, but waxes are just in nature very long esters, simple esters. Now, how many of you have heard about waxing your car? And I have an older car. It's about more than 15 years old, an Explorer, but it's working great. I was going to buy a new one this year, but with the pandemic and the trouble getting chips and making the price of cars higher, I'm going to wait a year. And one of the things, if you look at my car, other than one little tiny spot with a little bit of rust, I mean, it's tiny, you got to look, it looks almost brand new. Why? Because religiously, used to be when I was younger, I'd do it 3 times a year. Now I do it twice, and I did it this weekend. I wash and wax my car. And the best wax has, car wax has carnauba oil or wax in it. And I buy this at O'Reilly's. Everybody see the Formula One on your screen? It used to be called until about 2-3 years ago Kit, and they changed it. And carnauba wax is the best wax for polishing your car. And what it does is it protects the metal and the paint. You don't think of it, but paint is a coating on your car. And because of that, it keeps the water off there because of light, the cell's light. This is non-polar, and it keeps the water off there, which helps protect the finish and gives it a nice shine too. And in fact, my neighbor last summer, when are you going to buy a new car? And I happened to say, have you looked at the body of my car? He said, yeah, it looks brand new. How old is it? And I said, well, it's a 2000 Explorer. Wow. Not I'm thinking of it, it's over 20 years old, but I maintain it and I wash and wax it twice a year. Now, one other thing, because I know light dissolves light, I have a semi-heated garage, which means some of the heat from my house escapes into my garage, even though the walls of the garage itself, my garage door, are insulated. What that means is that in the winter, when in my garage, the temperature is above 32, which when it's 20 out, it's above 32, I can take a bucket of water, or actually first what I do is soap and water. I use a rain dance soap, and I do what I call a sponge bath in my garage for get all the salt and everything off my car body. Now, use that, and I'll dump the bucket a couple times and do fresh soap and water with a towel. Then I'll take the same bucket, clean it out, this fresh water and another towel, and rinse off, dump that a couple times, a couple towels, and it's brand new. I guess I go to a car wash too, but if it's cold enough, I don't want to do that. It might freeze on the car, and that keeps the salt off. And with the wash and the waxing I do, body looks beautiful. All right. Let's go back to class. I hope you enjoyed what I just taught you. Now, switch will be off, but I talked about liquid hand soaps. Let's talk about detergents. Detergents do the same thing. I won't ask on a test, but all your detergents like all, Cheer, Tide, use this is the main chemical. They have other additives, that they're all about the same. I use all. My parents did, and I stuck with it, and it works fine for me. This has nonpolar tail. And right here, I have a polar head. And when you wash your clothes, guess what? You're forming micelles, and that cleans the dirt off your clothes or grease. And that's how it works. And how they came about this was right at the end of World War II and everything. They developed this and found this worked a lot better than other molecules. In the old days, they used to use bar soap, like you see on TV in the old Wild West with the washboard and all that. No, I wasn't alive when they did that. But anyways, this works quite well. And this also, because of this different type of tail and head, has different solubility properties. That's why you don't see bathtub scum or washing machine scum in your washing machine. All right, a couple of quick things. I'm going to turn the switch off for the following, but I thought I'd talk about it. That's Phosphoacl Glycerols. And what they are triesters of glycerin, in which two hydroxyl groups on glycerin have fatty acids, just like that. And the last one is alcohol esterified, making a phosphate ester. And it has this structure, and it switches off, but still interesting. I'm running out of room here, sorry. Actually, that's a minus. You don't have to write this down. And this is what phospholipids are. And here you have, just like in a fat or oil, your esters, but here you have what's called a phosphate ester. And this is an important molecule in our daily life. The name for a common one is called lecithins, and it's found in egg yolks and soybeans. Now, personal thing, when I eat a lot of soybeans, that's the Edamante or the green ones without the shell around it. I just buy it, I boil them like they say, and then freeze them and put them in everything. I sleep better and I think better. And this plays a role, the phospholipids, I believe, in your brain and your body. So when I get away from it, my sleeping, and I'm back to my soybeans and different dishes I have soybeans in, and it helps me. Now, another place you can find this is in egg yolks. If you look at lecithin, it's a yellow solid. I wonder why egg yolks are yellow, because of that. Now, if you're familiar with mayonnaise, mayonnaise is mainly water and vegetable oil. But wait, you said they would separate. And they would, except when you make mayonnaise the old-fashioned way, use an egg, really an egg yolk, water, and vegetable oil. And the phospholipid is a surfactant. Here it has a polar head, and this long tail here is nonpolar. And that helps keep the water and vegetable oil together. So next time you see mayonnaise, and Dr. White likes mayonnaise, but I got to stay away from it. It's not good for me. Keep my triglycerides down. But it's got egg yolk, water, vegetable oil, I think lemon juice, and some seasoning, salt, and whatever else. And that's how they make mayonnaise. I bet you never thought we'd get into mayonnaise in this class. We did. All right. Now, long ago, and hold on while we go all the way to the beginning of this chapter. I talked about two types of lipids. You should know, again, this is for test number 4, not 3, coming up this Wednesday after class. Excuse me. There are two types of lipids. One is saponifiable, that makes fatty acids, carboxylate anions of fatty acids. You now know that's fats and oils. The other type is a non-saponifiable lipid, and they don't undergo base hydrolysis, no reaction. Well, what are those? Let's learn about those. And those are what we call the steroids, otherwise known as your hormones. Now, all your steroids, your hormones, have this 4 rings together, and you should know how to draw this. And let me show you how to do it. You have a 6-membered ring, and right next door on the right, you have another 6-membered ring. Then right up here on the second ring, you have another 6-membered ring, and then to the right of this 6-membered ring, you have a 5-membered ring. And you should know how to draw this. Now, this is the ring skeleton for all of our hormones, steroids. And let's have some fun now. Now, I'm going to get into stuff that, remember, I'll talk about things that are organic chemistry in no way indicating any moral stance on it. Give me a second while I find things. This. Don't you just love Google that always corrects my spelling errors? All right, we're all set to go. Now, let me move this out of the way. Does everybody see that structure on your, with the carbonyl, double bond? Now, these little wedges, this one right here at the end with nothing, First of all, that shows stereochemistry. Is that group coming towards you above or below the ring? And that's a methyl group. You have hydrogens here, another methyl group, and up here you have an alcohol. This is testosterone. This is the male hormone. This is responsible for my beard and other things. And it's also found in women to a smaller extent. And this is the male hormone, or if you notice, 6665, that steroid ring system. They're also called steroids. Now, this is progesterone. Progesterone has the same ring system, 6665, has a carbonyl, carbon double bond to oxygen, double bond, but where testosterone has an alcohol on the top of the 5-membered ring, here you have an exocyclic outside the ring ketone. And this is important female hormone. Now, let me think, what's the difference between men and women? Oh, I know. Men are alcohols and women are ketones. Doesn't that explain everything? Not really. Now, let's look at a very other important female hormone. And this is estradiol. This is the hormone of steroid that controls a woman's monthly cycle. By how much a woman's body produces controls the time of the month. And notice it has 6665, the steroid ring skeleton. Now notice here you've got a benzene ring, aromatic ring, with a hydroxyl group, alcohol there. And on this 5-member ring, you have a hydroxyl group. Now, this is an expensive molecule to make or obtain, very expensive. Well, it turns out organic chemists were able to do something very interesting. Make this molecule. And the only difference is where in the 5-member ring, in estradiol, you have an alcohol. Now you have an alcohol that also, instead of having a hydrogen on the carbon with the hydroxyl group, you have a triple bond. And you did a Grignard, you can make this from a molecule where this is a carbonyl. And you react with a Grignard type molecule that's a carbon-carbon triple bond. The precursors to make this are inexpensive. This is called ethynyl estradiol, and a woman's body can't tell the difference between this molecule and the actual natural molecule. And this molecule, ethynyl estradiol, which is inexpensive to make, is the key active ingredient in birth control pills. Again, I'm not doing any moralistic, but if you think about it, birth control pills has had a major impact on our world that allowed women who want to choose to control whether or not they get pregnant. How does it work? The different pills they take during the month have different levels of this compound. And that allows you to override, if you're a woman, your body signals that, oh, I shouldn't have my period because I'm pregnant. No, this forces your body to do that and inhibits a woman from getting pregnant. And that's organic chemistry. But the key thing you should know is how to draw the steroid ring skeleton 6665. And like I have here, hormones and our chemical messengers. This won't be on it. I don't know what the heck a ductless gland is. I didn't know I had any ductless glands. It was in the book and I copied it out of there. And we're through with fats and oils. How are we doing time-wise? All right, don't forget the important things I taught you today. One was use hair and grease remover, cleaner, drain cleaner from Home Depot. I haven't seen it in the other big box store, Home Improvement. They always have it, and it works like a charm. I've used it both in my bathroom sink. Luckily, my tub or shower haven't clogged up yet. Well, I'm surprised, but I also have on there a hair catcher. Not that I have that much hair to catch, but I lose some every once in a while. And don't forget how soap works. Next time you're washing your hands, think about, are you making micelles? Not micelles. Ooh, that was a bad joke. I'm sorry. And the other thing I taught you was how to clean a bathtub real easy. Use Barkeeper's Friend, wet it down with some hot water, sprinkle some of that on, rub it just so it forms a light paste on everything, and just leave it alone for 10 minutes and come back. And don't use the sponge because it gets fouled up. Use some good quality paper towels. Just rub it, moisten it, rub it if there's real bad spots, and then spray it down. I have, like I said, the removable shower head, and my bathtub shower head is also removable. And it makes the worst job in my home not that bad. And I'm going to do something totally unusual. Don't tell the dean. I'm going to end 2 minutes early. If you have any questions, I'll stick around. Don't forget, tonight I have my office hour from 5 to 5:15. If you have any questions, give me a call. Stop by Zoom and I'll help you out. With that, I'm going to say, gang gesund. Bye now.